Welcome to grade 11 chemistry, hydrogen bonding. All of you know that ice floats in water because it has lower density than water. What makes its density lower than water? Water has lowest molecular weight among the hydrides of group 16 elements. Yet it has highest boiling point. Why? This is due to hydrogen bonding. We know that elements like fluorine, oxygen and nitrogen have highest electronegative values. Fluorine electronegativity is 4, oxygen electronegativity 3.5 and nitrogen electronegativity is 3. When these elements like fluorine, oxygen and nitrogen form bonds with highly electropositive elements like hydrogen through strong covalent bonds. Covalent bonds are formed by sharing of a pair of electrons. There will be partial charge formation because of high electronegativity difference. Fluorine has highest electronegativity value 4. So in hydrogen fluoride, fluorine attracts the shared pair of electrons towards it. So there will be a charge formation. As electrons are attracted towards fluorine, fluorine attains a partial negative charge, whereas hydrogen attains a partial positive charge. So there will be a force of attraction and a weak bond is formed in hydrogen fluoride. This weak bond is denoted by dotted line. So hydrogen bond is the force of attraction between strong electronegative atom. This fluorine is the electronegative atom and hydrogen, which is covalently bonded to another electronegative atom. This fluorine form a hydrogen bond with this hydrogen and which is covalently bonded to another electronegative atom fluorine, and this is hydrogen bonding. A hydrogen bond is a weak bond. A hydrogen bond is less stronger than ionic or covalent bond but more stronger than van der Waals forces. Ionic or covalent bonds are formed by sharing or transfer of electrons, whereas van der Waals forces are just force of attraction between two atoms or molecules. The conditions for hydrogen bonding are presence of highly electronegative atoms. Fluorine, oxygen and nitrogen has high electronegativity values, and there is a large difference in electronegativity values and small size of electronegative atom. We know that these elements at the right side of periodic table have small size compared to other elements. Factors that affect the strength of hydrogen bond. Number 1, polarity of the bond. If we compare this molecules HF, HO and HN. HF is the most polar because there is high electronegativity difference. Fluorine is high electronegative and hydrogen is electropositive. While HN bond is the least polar. So polarity decreases in this order. HF more polar than HO, which is more polar than HN. Second factor is extensiveness. It is the maximum number of hydrogen bonds a molecule can form from its neighbors. So extensiveness is a molecule that can form more hydrogen bonds with neighboring molecules. Some common examples of hydrogen bonded compounds are hydrogen fluoride, water and ammonia molecule. In hydrogen fluoride, fluorine is highly electronegative and hydrogen is electropositive. There is large difference in electronegativity values, and because of this there is charge formation. Fluorine is partially negatively charged and hydrogen gets partial positive charge. And this leads to formation of hydrogen bond. A large number of hydrogen fluoride form hydrogen bonds and leads to formation of a cluster of hydrogen fluoride designated by HFN times. In water molecules, oxygen is electronegative and hydrogen is electropositive. Because of the difference in electronegativity values, there is partial negative charge formation on oxygen and partial positive charge formation on hydrogen. A large number of water molecules bond together by hydrogen bond and forming a cluster of water molecules. In ammonia also, nitrogen is electronegative and hydrogen electropositive. There is charge formation and a large number of ammonia molecules form bonds forming a cluster through hydrogen bonding. Hydrogen bonding is denoted by dotted line and the solid line represent covalent bonds. Now let us discuss the different types of hydrogen bonding. There are two types of hydrogen bonding: intermolecular hydrogen bonding and intramolecular hydrogen bonding. In intermolecular hydrogen bonding is between hydrogen and an electronegative element of two different molecules of same or different substances. Example: hydrogen fluoride, water and ammonia. In all these molecules, hydrogen bonding is between hydrogen and an electronegative element of two different molecules of same substances. In intramolecular hydrogen bonding between hydrogen and an electronegative element present in the same molecule. For example, orthonitrophenol and salicylaldehyde. In orthonitrophenol, there is hydrogen bonding between hydrogen and oxygen of NO2 group. The hydrogen bonding is within the molecule, within the same molecule. And in salicylaldehyde, there is also hydrogen bonding in the same molecule. Now let us discuss the effects of hydrogen bonds on physical properties. Molecular weight. The experimentally determined molecular weights of a number of compounds come out to be higher than their formula weight. This is due to association of molecules through hydrogen bonds. For example, in carboxylic acids, two molecules of carboxylic acid associate through hydrogen bonds and form a dimer. So the experimentally determined molecular weight of carboxylic acid is found to be higher than its formula weight. The second one, physical state. Molecules of compounds in which hydrogen bonds are present come closer to each other and attain solid or liquid state. The third one, melting point and boiling point. Stronger the hydrogen bonding between molecules of substance, greater will be energy required to separate the molecule, and melting point and boiling point will be high. Now you can see why the boiling point of water is high. Because of hydrogen bonding. More energy is required to break the hydrogen bonding and separate the molecules. So the boiling point is high for water. The fourth one, solubility. Hydrogen bonding also accounts for solubility of compounds. The lower alcohols, methanol and ethanol are highly soluble in water. Ethanol is freely miscible with water because of hydrogen bonding. Let us come to the last part of this section, why ice floats on water. In ice, hydrogen bonding between water molecule is more extensive than in liquid water. A substance in solid state has a definite structure and molecules are more rigid relative to one another than in liquid state. So in ice, water molecules are tetrahedrally oriented with respect to each other. Here, oxygen atom is tetrahedrally surrounded by 4 hydrogen atoms. And this gives rise to an open cage-like structure. There are number of holes or open space, so volume increases. As volume increases, density decreases. When ice melts, a large number of hydrogen bonds are broken. Therefore, the molecules move into the holes or open space and come closer to one another than they were in the solid state. This results in large increase in the volume, decrease in the volume and density increases. This is why the ice floats on water.